We are now going to look at the Playfair Cipher. The Playfair Cipher, in terms of coding it, it's more complicated. It's the most complicated thing you will have done. So we are going to break down this video in a couple of different parts, and we are going to explore each part, on its own, because the complexity of the coding is definitely has increased by a lot compared to the other ciphers that we have looked at, like the monoalphabetic cipher and the Virginia cipher. So this is the Wikipedia page for the Playfair cipher, and you should definitely read through the Wikipedia page. It's pretty good. And the other thing about the Wikipedia page is that it does go to a work example of the Playfair cipher, and so we're gonna use that. We are gonna implement that work example in code, so that we can see that we are in line with what the Wikipedia page does, and then we have a high degree of confidence if we are able to perhaps use this key, the Playfair example, as the key, and implement the algorithm in here, right? These are the 4 rules that we talked about in class, and if we are then able to get out this output, then we are quite confident that we coded it rightly. For the Playfair cipher, the first part is actually the key. We're going to talk about the key. The key, unlike the other ciphers that we have gone through so far, we'll actually need to do a little bit of work with the key to set it up for the encryption. As you can see here, right? So if we are using the phrase Playfair example as the key, we would then need to translate it into a 5x5 matrix, right? So let's in this video we are going to look at how we can set up our key into a matrix. So you should be familiar with how to work with list in Python. In this case, we might be looking at a multi-dimensional list or not, but we're going to explore a little bit. Right, so the letters of the alphabet, I'm going to import the string module first. Right, or actually, I had a feedback that we need to be a little bit bigger in terms of font size, and so I'm going to actually go up to, I think, 18. Yeah, that's a little bit bigger. Okay, right, not that much bigger, it's just a little bit bigger, but hopefully that's helpful. Okay, so we're going to import the string module. Right, we have imported the string module, and we know that for the string module we have the A to Z. Right, so I'm going to store that here, and the first thing that we want to do in order to convert it into this matrix is to select a representation for this matrix. So that there's different ways of doing it. I could store it as a string like this, and then I would then have to, as we want to access the different rows and column, we'll have to figure out how, for example, a character in a certain row and column will map into a certain position into this one-dimensional string. So, I mean, the letter P, which is in the first row and first column, will map to index 0, the first character, while the letter I, which is in the second row, first column, will map into the sixth position, right, in a one-dimensional string. So we could do that, and that's actually pretty efficient code-wise. Our code will probably be quite concise, uh, but the math involved in figuring it out will probably be quite involved. Uh, it will be kind of hard to follow through, so I'm not gonna do that. The other way that we could represent our matrix will be literally quite as a list of characters, right? So we could say that our key will be like, for example, it will be the P, or whether we don't even need that, we could say like, the character P, and then L, and then A, and then Y. um, oh sorry, Play, yeah, that's right, and then F, and that is one row. um, and then in the next row we'll have I, followed by R, followed by E, followed by X, followed by M, and so on and so forth, right? And what that does is we have a list of lists, and so this is just the first two rows of um, our key. And this works. This is fine. This is great. You can actually do this. I'm just gonna condense it a little bit, and I'm gonna just have a one-dimensional list of strings. So the first row will be like that. The second row will be like that. The third row will be fourth row will be, and the last row will be. Right, so that would be the other way to represent the key. So I'm going to do it this third way instead. And we could be done here, but what I want to do is I want to write some code such that given a key as a string, for example, this Playfair example as the key string, for you to write code that will automatically create this matrix for us. What it needs to do is, we need to drop the letter J, because there are only 25 slots in a 5 by 5 matrix, and there are 26 letters in the alphabet. We need to drop a letter, and we're going to drop the letter J, and all the J's are going to be I's, right? And then the next thing that we want to ensure in our key is that letters are not repeated, they only appear once. So in the idea of Playfair example, the second time the letter A appears, we drop it. And if it appears again, we'll drop it. The second time the letter P appears, we drop it. The second time the letter L appears, we drop it, and so on and so forth. And then the rest of the letters appear, in order. So we want to write code that will be able to create this matrix given a key. Okay, so let's do that. Okay, I'm gonna import the string statement, and I'm gonna store all the letters inside a variable, right? And the first thing that I probably want to do is actually, we can actually remove the letter J. So let's replace the letter J, and we're gonna remove it with a dot character, just to tell us that, okay, this letter is out. Okay, and let's print our string just to see that the letter J has been taken out, right? As you can see, where J is supposed to be, it's been replaced by a non-alphabet character. It's been replaced by a punctuation. Okay, right. So let's say our key is, in this case, Playfair example, right? So let's, and our I guess I'll call it the key matrix will be right now an empty list, and each row has 5 characters, and we need to keep track of that. So I will have an index I'll create an index variable to keep track. So whenever it reaches 5, we are going to go on to the next row. We are going to iterate through every character in the key, right? So we'll go for C in key, and that's going to go through the characters P and then L and then A and then Y, and then we're going to use that to build our key matrix. First things first, we want to make sure that our character is part of the ASCII lowercase, right? So if it's a punctuation, we actually want to ignore it. For example, there's a space between Playfair and example. So we want to ignore it. And actually, I'm going to go even further, right? If the letter has actually been used, we're actually also going to ignore it. So, and how we do that is that we're actually storing it in, this A to Z matrix, is A to Z string. So only if the character is the letters A to Z and it has not been used before, then we are going to consider it, right? So if that's the case, we will add it to our key matrix. And I guess in this case, we actually need to know which row we are into, right? So we'll need to kind of have both the row column and the row there, right? So we'll say key matrix which we are talking I, we are actually going to add our character to it. Okay, we are going to add that character to the end of our row, and then we'll do a check if we reach the end of the row. If so, and then we are going to increment the variable j by 1, saying okay, we have added a character, so j goes up by 1. If j is more than 4, right? So we have already put in 5 characters in this row. Then we are going to go on to the next row, and j gets reset to 0, right? Okay, so let's print out what is our key matrix once we are done with that. Ooh, list index is out of range. Right, okay, so what happens is that I will need to create actually 5 empty rows, right? And I'm going to use list comprehension for that. So list comprehension is something in Python that's 5. Is a kind of syntactic sugar in Python to kind of to do like a for loop kind of thing. So you can use a for loop, or you could use if a little bit more compact would be to use a list comprehension, and you can actually look up how to use list comprehensions online. Okay, so let's run this again. Right, okay, so we have the Playfair example. Not quite right, because the letter A is repeated 3 times, right? So we actually need to do more accounting when we've done that. So what we need to do is, once we have added it to the key matrix, we are going to tell the A to Z that we are replacing that character with the dot character. Okay, so now we can run module again. And in fact, what I'm going to do is, no, that's fine. Okay. And now you see that it works. We can compare it with the Wikipedia example. You can see the first row is play F, and then the second row is IREX M, and that's, oh yes, that's exactly what we want thus far, right? Okay. I'm actually going to print out the the A to Z string every time we do this so that you can see how it progresses. Right? So what happens is that for every character that gets added to the key matrix, in the A to Z string, it gets taken out, it gets replaced by a dot. So the next time around, when we do this check, if C in A to Z, if the letter appears again, it will fail this test because it has been taken out from the A to Z string. Right. So we need to finish filling in the rest of the matrix, and that will be just by going to all the letters in A to Z, and if that is not, actually we could just say if it's not the dot character, right? Then we'll do the same thing to j plus equal to 1. So I'm doing the same thing that I am, it's the same algorithm as above to build out our key matrix. In this case, I'm not bothering to update the value of A to Z. There's no need. We won't need to do this bookkeeping, right? We could if we wanted to, but there's no need to do this bookkeeping. So we're not going to do that. And let's run this module and see where we are at. Right. So we have a key matrix here. I just want to compare it against this one to make sure that it's right. It looks correct. You know, it's exactly what the matrix that you see on the Wikipedia page is. Okay, so this code is how you can then create a key matrix from a key string. So I could, for example, change this to another key. So let's say the secret that you share would be, for example, let's say the apple tree in the garden, maybe, right? And we run the module, and we'll see that, so this will be the key matrix that comes out from using the apple tree in the garden as our key string, right? Or the secret could even be just a random phrase, and it will still work. It will still generate a key matrix for us based on that. Okay, right. So I'm gonna put this back into what was the key Playfair example, and then we are going to move on to the next part of implementing our encryption rules.